Welcome to episode 8 of our deep learning series. In this episode, we're diving deep into the world of deep learning. We'll explore what deep learning is, delve into the basics of neural networks, introduce you to powerful libraries like TensorFlow and Keras, walk through building your own neural network, and unravel the concept of backpropagation. By the end of this episode, you'll have a solid foundation in deep learning and be ready to start creating your own models. Let's get started. What is deep learning? Deep learning is a subset of machine learning that uses neural networks with multiple layers to learn and extract patterns from vast amounts of data. Unlike traditional machine learning algorithms that require manual feature extraction, deep learning models automatically discover intricate patterns and representations in data, making them incredibly powerful for tasks like image recognition, natural language processing, and more. The evolution of deep learning. To understand the significance of deep learning, it's essential to appreciate its evolution. Initially, machine learning algorithms required domain expertise to engineer features manually. This process was time-consuming and often limited the performance of models. However, with the advent of deep learning, we can now automate feature extraction, allowing models to learn directly from raw data. Real-world applications. Deep learning powers many of the technologies we use daily. From voice assistants like Siri and Alexa to recommendation systems on Netflix and YouTube, deep learning is behind the scenes, making these technologies smarter and more efficient. It's also used in healthcare for diagnosing diseases from medical images, in autonomous vehicles for navigating roads, and in finance for detecting fraudulent transactions. Neural networks and deep learning basics. Neural networks are the backbone of deep learning. They are designed to mimic the structure and function of the human brain, consisting of interconnected layers of neurons. Let's break down the key components and concepts of neural networks. Key components of neural networks. 1. Layers. Neural networks are composed of layers. Input layer. The layer where the data enters the network. Hidden layers. Intermediate layers where computations and feature extractions occur. Output layer. The layer that produces the final prediction or classification. 2. Neurons. Each layer consists of neurons that perform a weighted sum of inputs and apply an activation function to introduce nonlinearity. 3. Weights and biases. Weights are parameters that are adjusted during training to minimize the error. 3. Biases are added to the weighted sum to shift the activation function. Activation functions. Activation functions introduce nonlinearity into the network, allowing it to learn complex patterns. Common activation functions include 1. Sigmoid. Squashes the output between 0 and 1. 2. ReLU. Rectified linear unit. Outputs the input directly if it's positive, otherwise, it outputs 0. 3. 10H. Squashes the output between 1 and 1. Loss functions. Loss functions measure the difference between the predicted output and the actual target. The goal of training a neural network is to minimize this loss. Common loss functions include 1. Mean squared error, MSE, used for regression tasks. 2. Binary cross entropy, used for binary classification tasks. 3. Categorical cross entropy, used for multi-class classification tasks. Optimization algorithms. Optimization algorithms adjust the weights and biases to minimize the loss function. The most widely used optimization algorithm is gradient descent and its variants, such as 1. Stochastic gradient descent, SGD, updates weights using a single data point at a time. 2. Mini-batch gradient descent, updates weights using a small batch of data points. 3. ADAM. Combines the advantages of AdaGrad and RMS-Prop, adapting the learning rate for each parameter. Introduction to TensorFlow and Keras. TensorFlow and Keras are powerful libraries that make it easier to build and train deep learning models. Let's take a closer look at each. TensorFlow. Developed by the Google Brain team, TensorFlow is an open-source library that provides a flexible ecosystem for building and deploying machine learning models across different platforms. It supports various tasks, from training models on large datasets to deploying them on mobile devices. Keras. Keras is an open-source neural network library written in Python that acts as an interface for TensorFlow. It simplifies the process of building neural networks, making it accessible for beginners while still being powerful enough for advanced users. Keras provides a user-friendly API, allowing you to build and experiment with neural networks quickly. Hands-on. Building a neural network. Now that we have a theoretical understanding of neural networks, let's build one using TensorFlow and Keras. We'll create a simple neural network to classify handwritten digits from the mnist dataset. Step-by-step guide. Step 1. Install TensorFlow and Keras. Before we start, ensure you have TensorFlow and Keras installed. You can do this using pip. Step 2. Import libraries. First, let's import the necessary libraries. Step 3. Load and preprocess data. Next, we'll load the mnist dataset and preprocess it. Step 4. Create the model. Now, let's create a simple neural network model. Step 5. Compile the model. Next, we'll compile the model. Step 6. Train the model. Let's train the model using the training data. Step 7. Evaluate the model. Finally, we'll evaluate the model's performance on the test data. Congratulations! You've built and trained your first neural network. This simple example demonstrates the basic steps involved in creating a deep learning model. You can further improve this model by experimenting with different architectures, activation functions, and optimization algorithms. Understanding backpropagation. Backpropagation is a critical concept in training neural networks. It involves adjusting the weights of the network in reverse order to minimize the error between predicted and actual outputs. Let's break down the process of backpropagation. Steps in backpropagation. 1. Forward pass. During the forward pass, the input data is passed through the network layer by layer to compute the predicted output. 1. The loss function then calculates the error between the predicted output and the actual target. 2. Backward pass. During the backward pass, the error is propagated back through the network. 2. The gradients of the loss function with respect to each weight are calculated using the chain rule of calculus. 3. Update weights. The optimization algorithm uses these gradients to update the weights and biases. 3. The goal is to minimize the loss function by iteratively adjusting the weights. Visualizing backpropagation. Imagine you have a simple neural network with 3 layers: an input layer, a hidden layer, and an output layer. During the forward pass, the input data is processed through the hidden layer and the output layer to generate predictions. The loss function calculates the error between these predictions and the actual targets. During the backward pass, we calculate the gradient of the loss with respect to each weight. This gradient tells us how much the loss will change if we adjust the weight slightly. By using these gradients, we update the weights in the direction that reduces the loss. This process is repeated iteratively until the loss converges to a minimum value. Conclusion. In this episode, we've covered the essentials of deep learning, including what deep learning is, the basics of neural networks, an introduction to TensorFlow and Keras, hands-on model building, and understanding backpropagation. Deep learning is a powerful tool that can unlock numerous possibilities in various fields, from healthcare to finance to entertainment. As you continue your journey into deep learning, remember that practice and experimentation are key. Dive into real-world projects, experiment with different architectures and algorithms, and stay updated with the latest advancements in the field. Deep learning is a rapidly evolving domain, and there's always something new to learn. Thank you for joining us in episode 8. If you found this video helpful, don't forget to like, subscribe, and turn on notifications for more insightful content on deep learning and AI. Feel free to share your thoughts and questions in the comments below. Stay tuned for our next episode, where we'll explore more advanced deep learning techniques and applications. Happy coding!